In this lesson, we're going to be investigating what's happened to this boat. Now we can see that this boat is quite old, it's dilapidated, and it's showing signs of disrepair. We can see the discoloration on the side of the boat, and we can see that some of those materials have started to break down. And why might this be? There's probably a whole range of reasons. It's probably been in the sea, it's been exposed to a lot of bad weather, and the oxygen and the water that it's been exposed to and the salt in the sea has started to corrode and break down some of the materials that the boat was made out of. So in today's lesson, we're going to be looking at this corrosion, what it is, how it's caused, and how it can be prevented. For this lesson, we're going to be using pages 71 and 72 in our booklets. We're going to go through some of the content and theory on page 71, and then you're going to have a look at page 72 to see if you can think about what might happen. So our lesson is on corrosion and its prevention, and the key words that we're going to be looking at are corrosion and sacrificial protection. And throughout this lesson, we're going to explain what corrosion is and how we can protect materials from it. So what is corrosion? Have a think. What do you understand by that word? The definition that you need to know of corrosion is that it's the destruction of materials by chemical reactions with substances in the environment. These substances are commonly things like oxygen and water that are reacting with materials. Rusting is a specific example of corrosion, and often people get the two terms interlinked and mixed up. Rusting is only talking about the breakdown of iron, and both air and water are necessary for iron to rust. You can see rust in this picture as that common orangey red colour, and it's where the iron, the metal, has reacted with oxygen in the air to produce iron oxide, which has that distinctive reddish colouring. We only talk about rusting when we're talking about the element iron. Other metals do not rust, they corrode. So how can you prevent corrosion? Can you think of any examples that you could do to prevent something from corroding? Well, there's a range of reasons that you need to know, and most of them are about applying a coating that will act as a barrier to stop either the water or oxygen getting to the material that you're trying to protect. This could include greasing, painting, or electroplating. Greasing provides a physical barrier to air and water, and it's really useful on moving parts because it won't chip or get damaged. Painting, similarly to greasing, also provides a protective physical barrier to both air and water. However, painting can chip when it's damaged, and any chip is going to allow the exposing of the metal below to the air and water. So in moving parts, we tend to use greasing, whereas on longer term things that aren't going to move, like window frames or door frames, we tend to paint. Additionally, we can also use electroplating. In electroplating, we use electrolysis to put a thin layer of metal over an object to protect that object. That metal can either be less reactive to try and find a physical barrier, or it can also be more reactive. Let's have a quick look at how we protect aluminium. Here we've got two sets of nails, aluminium nails and iron nails. Both of these nails are going to be exposed to the air, so they're going to react with oxygen. Aluminium oxide is formed when the aluminium reacts with the oxygen, and iron reacts with oxygen to form iron oxide or rust. Aluminium oxide is actually a really good protective coating that actually protects the metal from further corrosion. So the aluminium oxide on the outside of the nail acts as a barrier, stopping other oxygen or water getting to the aluminium inside and protecting it. This isn't the case in iron oxide, where the iron oxide on the outside flakes off, exposing more iron, and eventually the nail will rust until it no longer performs its function. As I said earlier, we can do what's called electroplating, and an example of this is sacrificial protection. In sacrificial protection, what we do is we coat a nail with a more reactive metal. So for example, here we might have iron nails like earlier, but we don't want them to be exposed to the oxygen and rust, so we'll coat them in a much more reactive metal, such as zinc. What will then happen is that the zinc will react with the oxygen, preferentially protecting the iron nail, and even if the surface layer gets scratched and the iron below is exposed, the oxygen will still react with the zinc rather than the iron, protecting the structure of the nail and allowing it to perform its function. We call this sacrificial protection because we're sacrificing the zinc to protect the iron of the nail below. So that's the theory that we need to know on page 71. We're now going to move to page 72. On page 72, we've got a whole range of examples. What you need to do is think about and predict what will happen to the nail in each of these different situations. You've got 8 minutes to do that. So I'll put a timer on the screen, and when it's complete, we'll go through the answers. So let's review the answers. What's going to happen in this situation here? Well, here we've got an iron nail, and you can see that it's exposed to the water and also to the air as the test tube is open. So over time this nail is going to rust because it's been exposed to the air, the oxygen and also to the water. In this situation we've got a stainless steel nail. So a stainless steel nail is iron mixed with other metals, and what this does is it reduces its ability to rust. So in this example, although it's still exposed to the oxygen and the water like the previous example, it won't rust because it's made of stainless steel. In this example, the iron nail has been painted. The paint will act as a physical barrier, stopping the oxygen and the water getting to the iron inside. So again, this iron nail will not rust. In this example, we've got a rubber stopper, and that will stop anything coming in, oxygen or water from the outside. And we've also got the dry air. Dry air will obviously contain oxygen, but it doesn't contain water. That's the key, calling it dry air. And so the iron nail inside will not rust because it's not been exposed to both water and oxygen, only being exposed to oxygen. And finally, this nail, again, will not rust. The oil is stopping anything else being added in the excess water or oxygen, and the boiled water means that the oxygen has basically been removed from that water through the process. And so again, because it's not exposed to any oxygen, the iron nail will not rust.